Thank you for having me. Um, so I'm going to start off with a reference guide that I've built, especially for the ones that are going to probably come in and probably be part of a building insurance or for your customers who's gone through insurance um, uh, issues. So this reference guide I can share with the building biologist. You can use where the ATRA logo is. I can give you an empty one. You can use it. The whole idea is to have a uniform understanding of how mitigation processes are. So, of course, safety is very important. So I will always put that in the first thing. Then the second thing is understanding site assessments, which we won't talk about it today. What we're going to talk about is measurements and how that is going to be established. Once a restorer has finished a site assessment, they've come in and did some measurements and realized that the event has occurred or where it has occurred. They're going to provide some recommendations, not only just to the homeowners, but to their contractors that they're contracted to, which will be then the insurance company. And the most important thing is to be able to do stabilization. Stabilization is a process that you start to mitigate moisture by removing any moisture that's in the air so that we can stop secondary damage. After stabilization has occurred and the insurance company and all the contractors have given approval to start start work, then step 6 will be actioned, where they will action, measure, assess, and complete. Or one of you building biologists might come in and provide what we call a PRV, and then the job completion will be done. And as you can see, the process in this is broken down. So I will send that through to you. However, that is not part of the topic that I am really talking about today. So what I really like to get into is just one of the a quick hands-on understanding of how and whys on moisture meter. I will be running through some of this quite quickly because I like to actually have more time for all of you to actually ask questions. As you can see, there's many moisture meters in the market, and moisture meters are not only for building restoration, but it's also for building surveyors, inspectors, and for what we call the indoor air quality professionals, or IEP, and or building biologists, and any of such professionals that in that indoor air quality space. So what is water damage professional? Is a person that's specialized, trained in skilled mitigation and restoration of property and effects of water damage and different occurrence, maybe heavy rainfalls or hurricanes. So the tools or the trades that you can see is from the left side is what we called the gentleman in the yellow vests bending down. He's using a non-penetrative moisture meter. Is a meter that looks at 2 conductive points through materials and get electric signals to come back, and then it will give you a measurements of sort. It is what we call a just a measurement. It's a qualitative reading. It's not a quantitative reading. It's kind of what we go, yes, we think that this material is wet. However, that can be hindered by if you are moving your meter across the building materials, and at the corners of a building materials, you will find that there's always some metal straps, and that might give you a false reading. And or if you have brake veneers, and some of the brake veneers at the back of the brake veneers have chicken pea wirings that holds up the insulation. And if you read your moisture meter, non-penetrative moisture meter, and you're scanning through it, and you got 100% throughout equally, it may not be a moisture issue. It could be just a material at the back end that has it. And also for building biologists that has going into EMF building, some of these property may have a shielding, and these shielding also will give a very a false, what we call false positive. Just note one thing: is a material is 100% saturated, you can really poke your fingers into it. So if you put into a plaster wall, it's not poking into it, it may be something is wrong. Hey, it probably is not a moisture in the material. It may be just something that is creating that false reading. Okay. Then in the middle, you see a meter with 2 pins, and that does conductive reading. And the conductive reading is more quantitative. It's something that we will say that that is a more accurate reading. It is literally going into the material, looking at the material itself and the substrate so that we can see how it is. I'm going to stop here for 1 second and show you a photo of what I mean in here. So this is taken from a friend of mine who was looking at a building material. He, as you can see, is drying some floorings here. So what he did is that he looked at the bottom, the top of the, sorry, we'll start from the left-hand side. And the left-hand side is looking at the bottom of the material. So he's pinned it all the way through, which means that he's looking at the back of the boards, pinning it all the way through to look at the back of the boards, and or possibly even a joist that's behind it. Then the middle bit is that when he comes back in, or as he's hammering his hammer probe down, he'll read the top, he'll go into the middle, and then he'll go right through to the bottom of the material. Why is he doing this? He's trying to see if there's any bound moisture in it. So water on the top surfaces will always, the boundary layers always dry faster, because you might have some fans that comes in and it's exposed to aerations and circulations, so that this is drying much faster. And the bottom of the material might be the same, is that they may be on a substrate and there's ventilation underneath and the materials either have not penetrated all the way through and or is drying faster. But bound moisture is the moisture that's in between, means that there's no escape for it to, is not so easily where moisture is escaped, and sometimes will need more energy where it can then penetrate, where it can wick up the material, especially when a material is dried on a surface and they break that capillary action. That capillary action cannot then elevate itself up where the moisture can evaporate. So in this particular instance is that he's found that, yes, the materials on top and the bottom may be dried. However, he is now using an injector dry system, which is on the bottom, looking at capturing the moisture that's in the bound material. We'll go back to the presentation itself, and then you would see that on the right-hand side, they're looking at the left-hand side, they have a dehumidifier. And a lot of time, the hydrometer is to look at if the dehumidifier is working. For us, IEPs and building biologists, we like to know what the temperature, the humidity is, so that we can look at the psychrometric of the building to see what the grains are in the moisture, which grains per pound moisture in the air, or the enthalpy, the moisture within building materials. And we want to see if there's evaporation potential, so that we can actually know if there's any ways that we can actually help our customers to actually try and remove some moisture, and if or the restorers are doing the job by removing some moisture. So then you'll also have what we see on the bottom with the telephone. That is what we call a sensor that is actually put onto a wood stud material. So if you have a customer who's got subfloor issues and you want to data log it, you want to see how the trending is for a week to see if there's moisture coming in. Is it something that is caused by a ventilation issue, or is it something caused by living condition or such, then this type of information is very good. On the next slide, you may not be able to see, but there's two little blue points there. I put a sensor push onto a crack concrete ceiling. They've been trying to look and see what has been happening on this concrete ceiling. And they said that it is an issue, and the homeowner thinks that it's another issue, and the builder thinks that it's something else. So for me is that I think that it's a water penetrating through the silicon in the top balcony area. So the only way to do it was to put a data logger there. We looked at when the rain came through, how fast it penetrated. By looking at how fast the humidity rised, we could then determine if it could have been what either one of us has suspected. And then the last thing, I think the next one is also the pin reading, which we talked about. So we'll move back. What is a building inspector? You guys are that. You are the people that goes into a property and look at building that has either issues, is it a living condition issues, or is it a building issues from either poor insulations that has to thermal bridging, or is it a duct leaking or a drainage, or was it a water damage? So all these are the stuff, and this is what we'll be talking more. This is more what you guys are. So some of the moisture meters that are also used is that if you are looking at efflorescence on the side, you can use either a salt calibration. There's a salt kit that looks at nitrates and calcium, and they're very good for concrete, especially if there's efflorescence. And efflorescence are salt sediments that are on concrete that are pushed out because all concrete has sediments in it. And sometimes when there is water logged, then some of these materials will be pushed out through the water, because water is heavier than most other things, and it will just push out these. And these white little films starts to build on these surfaces, and those things are what we call efflorescence. And when there's efflorescence, people think that there's mold, and when there's mold, people would then think that there may be a living condition issue. However, there's ways to test it. The Speedy underneath that looks at gravimetric reading. Gravimetric reading is taking the salt sediments and measuring it in weight, and the weight will then, the salt sediments putting in liquid. The liquid will then weigh it, and let's start that again. You take the salt sediments, you weigh it on its dry or wet form, then you'll add a liquid that will then take that reading to prove if that sediments that is, and the weight of that, and how much weight there is. And the Speedy is one of those, is a gravimetric reading meter. There's also a pinball meter, which is the gang meter. So when we're looking at moisture meter, there is a lot of different things. The bowl meter or the oven meter is one of the hardest meter to use, because it looks at depth and circumferences around it. So if you're looking at depth, and if your meter like a FLIR bowl meter, it reads 100 mil, so 10 centimeter. It reads through the material on quite a depth. So if behind your material you have stud, nail, and such, it might give you a higher reading than what is supposed to, and you might pick it up as a false positive in reading. So using a bowl meter, it's really through experience to know the depth of the material and how far it reaches to really be able to use it correctly. We've also got Trimex. This is a Speedy meter. It shows you that you collect the sediments, you go into a jar. It will then will have a nitrate solution. nitrate solution. We'll then mix it up together, and then you can put it into a weigh and weigh it, and it will tell you how much moisture is in that material. So this is, again, a gravimetric reading. I'll provide you with a slide so that you can actually look at it, because I think gravimetric reading, a lot of people are still determining what that really actually means. And why is it important for us? It's important. We don't generally use it. However, if we have building materials that we really like to determine to exactly see what the moisture content is within that building material, we might use it in a more litigious circumstances, but our normal assessments, we really do not go that far. It's a little bit too above and beyond the cause. So the salt kit, which you can see, is using distilled water, and it will look at nitrate, which is soil, chlorine, which is what we find in our natural water. I find that this is a very cheap and very, very effective kit to use, especially if you look at concrete again. And if you find that there is nitrate and chlorine in that solution, you know that it's actually a water event. And if you see that it's only nitrate, means that there's actually a damp rising event. So those type of two information is very, very useful for assessment, because one may be an intuitive event and the other may be some more critical building failures that's happening. Again, the salt kit is here. You'll see it in the assess. So indoor air quality professional, we've already talked about that, so I won't go into it. Sampling and sampling methodology, I think that you'll go through this in your training. Again, there's a lot of different sampling methods out there. Some people are using ATP. Today, I've just done over the weekend, I've done a really good training on micrometer, and I find that the fungi analysis of the micrometer is very good. I'll do a presentation next time on it. There are also other systems that you can use, particle counter. This is one of the type of particle counter that you can come out with a report and such. Indoor air quality systems. Some of you do use this, especially if you're going into a customer, and this is only one of the brands. There's more brands than that. But an indoor air quality meter is very good, especially if you're looking at living conditions of your customers. Most of them do have PM 2.5, TVOC, temperature, humidity, and the Yuhu has 13 parameters. And so those type of meters, you can see the trend again to see how the condition of the environment, if they open a door at night, how infiltrations of how they live and such. I would suggest that we again probably do another session on that if you like to. Because it can go into very different form. Now, I'm going to just show you some of the kits that I have. Okay, so these are kits that I go out, I buy a box, and they're 50, 60 bucks. They're very, very, very sturdy. If I have to travel interstate, this box will go with me. I can cut into the kit because they come with foams. I just cut the kit together. And what you can see here is that I've got a hammer probe, so I can go into deeper materials. They're generally about 2 1/8 inch of materials, so they pretty much go into most everything. Then I have 2 types of torch. I have 2 types of laser measurements. When I go back to torch, I'll have one that's UV, so I can look at urine. If there's dog urine there, cat or dog pees and stuff like that are very good. Then I keep a couple of batteries, because if your meter has low battery, sometimes your reading could be incorrect too. And what I also have is that I've got a laser pointer, I've got a Trimex concrete meter here, and I've got a power. This is what you can buy. You can buy that on eBay for 20 bucks. It's called an electrical circuit meter. So it tests the circuit of electrical, especially if you go into a damp building, you don't know where the wirings is and what's working or not working. This type of meter can help you look at it. Then a laser pointer is very good because laser pointer can look at temperature on surfaces, and they can look at temperature on surfaces, and it will give you an indication of what that surface is and what is in the air. Protometer has one on the tip on the right hand. That little dot that you see with the light is a laser. It's a laser surface meter. So when you take that, you point it into a ceiling, not only do you see the laser light, but it also looks at dew point on a ceiling, should there be any. And that is a very good indication of moisture within a material that's wet. And of course, I've got a leveler. So if I'm going to look at wood floors and the floors are a little bit cupped, you know, sometimes the eyes can be deceiving because the wood might be leveled. However, we might look at it and it's just torn apart due to the age of the material and where we think, oh, that is cupped. However, when you put the laser measurer on it, the leveler on it, it probably just tells us that there's nothing wrong with it. So the laser measurer is very good. Then we look at, so that's another one, sorry. And then I've got one more only that I like to show you. That is on, and not anymore because I closed everything up. Okay. So on that note, I am going to finish the presentation. I like to spend a lot more time on having conversations because I think that's more useful than us than me showing you pages of document, I suppose. Hi, Brian.
Hi, Brian.
Hello.
Mm-hmm.
I guess you want me to ask the first question?
Yes. we're opening for questions now. If anyone wants to
all right,
ask
I'll kick it off. Evie, can you speak in depth about recording the temperature of the surfaces of the materials that you're measuring, and if it matters, and when, why, and how, and the arguments from other meters, and how that gets applied also to the protometer?
Well, the protometer, I was about to say protometer is the only meter that has the surface measurement available. However, I think Trimax have just come out with the MEX5. It's not available in Australia yet, but that one will have a laser pointer to it. So watch that space. Now, the surface meter is very good because if I was to look at the roofing of a building, which is right on top of that is a balcony on the, on the east side of winter, where sun doesn't come through, in a morning where it is really cold, and probably this balcony waterproofing has failed, and condensation, the temperature on the concrete is so cold that the back of the concrete is starting to sweat, because the bottom where the living space is, especially in winter, will heat up the space. So the temperature in our ambient space will always be around 24. If it was me, probably 28, no, 24, 25 in the building in winter, right? So because you've got your heater on, and so that might then migrate to the cavity. And if the cavity of the ceiling doesn't have an insulation, or if it has an insulation but not firmly packed onto the concrete, then there is a thermal difference. That thermal difference will then sweat. If you haven't seen, I've seen many slabs that has literally, when you go in there, you need a small little umbrella because it is wetting so much. So the temperature surface gun, if I point it to the surface, I will actually see a dew point, because the temperature within this space here and the temperature within the space that is impacted behind where the material and the concrete is cold, it will create a temperature difference. That temperature difference, if the material creates a high and has 100% temperature differences, is what we call dew point, and that will happen. Even if it doesn't have 100% differences, it has enough for it to impact. You will then see that there's a possibility of mold growth. The surface measurement temperature is very good, because then you can actually tell your customer and say that, you know what, we can see that there's something in the ceiling. I need to do a little bit more investigation. I probably might need to go into the roofing. I might need to cut a hole. I might need to take a downlight out, or go into a building, investigate maintenance hole to actually see that difference. The other thing that is very good, the surface, the only one that you can see that's different is like I was saying, these type of temperature guns that I probably shared just now will also be useful for that situation. If you don't have either any of the protometers so this is this here. This here is the point that Brian is talking about. So the sweating that you can see will give you a condensation value within the materials to see that difference. Does that help?
Brian, yes, you happy with that?
Yeah, I got more if you want me to keep asking, but
Yeah.
Does anyone have any other questions?
Yeah, don't let me take it all.
You might
So
have
let's
to
look at thermal imaging. Does anybody know the difference between what a thermal imaging camera does? Thermal imaging camera looks at temperature differences. It doesn't look at moisture. It doesn't look at mode. It only is a quick tool for you to be able to see, like in this photo on the right hand side, where there is a gyprock or a plaster wall, and you want to see what's happening at the back. In the left photo, it shows a little bit of watermark that you can see because there's a temperature difference between the material. You might go, wow, okay, I think it's there. Take the moisture meter, you go in there, you measure it, and it confirms your conclusion, and that would be really good. So imagine you're going into a 3-bedroom house, and you're going to have to use your moisture meter to go to every single surfaces. You might be there for 5 hours. However, with the thermal imaging camera, what you can do is that you can do what we call quick scan. You can go away and look at it and go, okay, I noticed one thing. The ceiling has no insulation. So there was always going to be some thermal difference in this house. Oh, I feel this house is a little bit colder. I can understand why. I look at the walls and go, these walls also don't have insulations on them. And then that gives you another indication. Or you look at it and go, I see a black spot there. And then you go closer to it with your moisture meter and be able to indicate if that is a moisture point or not. That can again tell you if they had a water damage affected or it is water damaged again. So thermal imaging cameras are very good to look at thermal differences in a building. The other thing that you might understand is ghosting. If you go into a place, somewhere generally around kitchen, barbecue areas, you would see black marks within a stud wall or the stud following the joist plates. And you're like going, why is that? That is mold, hey? You know, sometimes it's just that the thermal differences between the material has given the possibility of the carbon particulates or the particulates to actually attract itself to the surfacing, creating darker spots within those areas. So it not necessarily is mold, it's just dirt and debris, especially like when you're frying stuff, there's some particulates that comes in, and those particulates sticks onto the roofing because there was once upon a time a little bit of thermal differences, and they have created some sort of magnetic connections between each other.
Thank you. Any other questions? Mariana?
Hi, hello. I wanted to ask you to talk a little bit more about the digital environment tool. So can we see an example of a report?
Sure.
And how long does it log data for?
The digital environment, we actually have had a look at it, and it can do 24-hour trend reading. I go in to do assessments on building with the digital environment because I like to go in and get a really quick trend reading on a place. So give me a second. Right. So the digital environment is a particle counter. It has temperature, humidity, temperature. So in this, there's a particle, a laser pointer, a laser light that will actually let the particulates go through it, and it will read the PM 2.5 from the materials. So it also has a TVOC meter in it. It has temperature and humidity. The algorithm is connected through an app, and the app will then take on all the readings. You can look through your app, Bluetoothing it to see what is happening in the environment, to look at if there's any trend again. If I'm going closer to a moldy spot, I can see that there is the particulates a little bit higher. If I'm going to a carpeted area, I want to see how clean the carpet is. I stamp on it and I put the meter there. I can see the particulate going into extremely high conditions. Then I can actually see that there's a cleaning regime issues in the house. The occupant has particular issues. I might be able to help them to identify it a little bit faster. So the unit comes with a report. Again, if I was going to go into a premises and I'm going in there, I've got, I've decided that my business has a couple of inspection costings. Say I've got, let's say level 1, $395, a quick 2 hours assessments, read a report, send them a report. If further investigation is needed, or if I need to take some samples, I might have to provide that on a later date, then that's fine. Hey, then this this particle counter is very good for that type of assessments. It gives you a bit more depth in your business that you can actually probably provide to customers, because not everybody can afford sampling costing, say. However, sometimes you also know that when you go into a building, you can already tell what the problem is. So the living condition is poor, the humidity is high, and I can see mold everywhere. So those type of stuff, I just think, there's no need to really sample. You can really tell them that you've got, that's what you've got. And then again, like I said, this type of meter might be a good way of going. So the meter can, the app can then have your business logo on it, your location, where the area of testing is. It gives you a third-party diagnostics, who's done who is the company that provides these information, and where they got these information from. It's the GPS of it, all the notes that you require from the meter. You will then see that the outdoor area compared to the indoor area, obviously there's a depletion of CO2 in this particular area, and we can tell because there is mold in the building and such. So we'll go down. The references is they provide you with all the reference point that they come with. So they are taken from different EPAs and different federal agency data, and also, so it is third-party documented. It also tells you or give your customer a little bit of knowledge of what, you know, the microns are. So when you're talking about 2.5, you know, what sphere that lives in. So it's here. When the spares that you might have, 2.5 is between 1 and 10, you might have some mold spores, some allergens, bacteria, maybe less than 2.5 and stuff. And it tells you what sort of actions and recommendations that you have. It'll give you the site, you know, give you ability to take photos of it, and then gives you a trend reading of the material. I find it's very good because I can do an indoor-outdoor sample, you know, and I can do bit analysis. I can write down some informations, and it's pretty good. So I do like the meter itself. However, the downfall of that meter is that it is an app, and an app it costs money. And if I'm correct, it is it's about $70 a month for the app. But if you do 2, 3, or 4 reports a month, you'll find that that meter would be paid off with no problem. When I was using it, I was doing probably about 10, 15 reports a month. So for me, it was very viable.
And can I just ask then what the difference is with the sensor push?
Sensor push is a data logger. Hey, sensor push is it has four different types of meter, and let's get it. Hey, whoops, sorry, I've lost you here. There we go. So just going to the Great Web. Hey, that's a sensor push. So what it does is that it is a data logger that looks at temperature and humidity. It's very good. The sensors have humidity, so it can go into cold areas. So I can put this in my fridge, and it will still it will record under minus 10. So if you're going into cold room, like let's say you're doing an inspection, there's some mold on and that's what your job was, to go into a cold room and look at the mold situation there. Well, it's very easy. You can go there and look at it. There's mold there. Hey, however, how did the mold get there? And that's what your job was. Hey, so one of these type of meters will allow you to put into the cold room close to where the door is, where the mold growth is. And you can see when they open it up, how many times they open it up and how much temperature difference there is, how many dew point it is. This can calculate temperature, humidity, dew point, and vapor pressure. So, and they've also got one that has pressure differential. So when you see that there's pressure differential within it, then you know that, you know, somebody's come in and open up the window, open up the cold room, close the cold room. And of course, you can tell them, you know, you've got too much temperature difference, and dew point have impacted you, and people are either bringing in mold or causing mold to grow around the surfaces because there's too much dirt and debris that's coming in, causing an impact within that space. I hope that makes sense. So the other thing that I use, like I said, in the concrete space that I did, I put the sensor push there to look at rain that come in, and the builder thinks that the concrete slab has a wiring in between it, and the water came from the wires from the front of the front of the balcony, whereas I think that it was coming through on the top roof where the doors of the balcony is, and there's a sealant that was the issue. And with this sensor push, I put 2 sensors onto the concrete, waiting for wet weather to come through. We could have proved that it was correct, and then they did a dye test towards it. So sensor push are pretty good. They're what we call data loggers. They look at the trends, and with the trends, which is all these readings that they capture from everywhere, you know, from all the time that it's been placed here, you can actually look at it. You can go back to your customer and say, well, I looked at it between, you know, 8 and 9 o'clock at night. There was a high temperature difference there. Were you cooking at that time? Was there anything that was happening in that environment at that time that caused the temperature and humidity to spike up that much? Oh, I put my laundry out, hey. Then, you know, that might be why, hey. Okay. Does that make sense?
Yes.
Yeah, it's really good. It gave me the idea that it could be used, say, in someone's master bedroom that is next to their ensuite to monitor what's happening in the bedroom after they shower for, I don't know, half an hour or so. Could come in handy.
Very, very good. Hey, especially if they look at condensation that's coming out from master bathroom, you know, humidity that's in that room. And another indication might be a little bit, if you look on the side of the wall, it's sometimes very hard because the visual part is that you might not see water mist that's on the surface of the material. But sometimes when you use your torch on the side, you might be able to see watermarks, and that also will tell you that there's condensation within that wall. Hey, but yeah, a tool like a data logger is very important, like a IAQ sensor. I have had quite a few that I rent to my customers because they don't know what was an issue, and I left the sensor. I charged them $300, including my report, for a couple of weeks. So 2 weeks would be $600. And then what I do is I'll go and collect it, and then I'll take the data off it, and then I look at the trends that there is, and then I go and have a really good conversation with them to see, as you know, points that I've taken from those trend readings to be able to ascertain probably what the issue might be due to their living conditions and such. And with the data, it's easier to say, hey, you know what? You guys really shouldn't be putting your laundry there. You know, if they know, they probably know, they just do it anyway. Hey, but now you can show them with evidence, scientific evidence, that how it's impacting their health. And that's what you guys do, is that you use not only your skills, but also the apparatus that is scientific to actually give your customer something that is not just, hey, you know what? It's wet on the wall because my meter says it's wet. Hey, you know, your skill is what you have. And then you take that skill and that science from the meter and help your customers to determine the best, to your knowledge, how, you know, and what they are asking you the question. And if you don't, you just go and ask Brian, hey, because he can help, hey, and or any of your, but any of your ABBs is. I think that's the main thing, is that you have.
I can also be rented out at a cost.
Ka-ching! There you go. Yeah. So so we talked about the opportunities of using scientific informations and scientific instruments to help you to look at moisture reading. Moisture mapping. Does anybody know what moisture mapping is?
Yes.
Please, Brian.
No, Kelly was the one.
No, you go, Brian. You're good. Please.
No, I'm good. No, moisture mapping is essentially drawing a map of numbers, paint by numbers, using the moisture meter to develop a picture for where there are areas of risk and how far something, if there's a specific issue, how far it's gone. And in that way, you can then draw up a scope of work for that work if it's needed.
So most of you will, when you go into a premises, you might already have Googled the premises, or the homeowner is kind enough to give you a floor plan. Gone to many of them, go, I don't have a floor plan. And I'm not quite sure why you buy a house and don't have a floor plan. But anyway, I digress. So you will always be able to find one online. And once you have that, then you will actually be able to go in and pinpoint either areas that have issues. And like what Brian has said, is that you can then moisture map the areas. It's very important, especially when you're doing assessments for insurance companies, or if your customer has a argument with a insurance, is that you will have to be able to be as skilled as your opponent, you know, which everybody now calls hygienist. Everybody's hygienist now, so we'll use that term that is there. And the skilled hygienist will come in with the moisture map, knowing every inch of that building, what there may be or issues that are there. So you need to be able to document that, so that you can actually have a comparative information when you're having a conversation with these hygienists, which you actually are also one of them. Yeah. So moisture mapping is very important, hey? And I've noticed a lot of you guys and girls actually do have moisture mapping in your reports. So good on you.
Yes, definitely. Any other questions? Anyone?
Okay,
can
and
add.
there is a test that
I can add
Yay.
another one. Evie, there is an argument from a different moisture meter crowd to Protometer regarding measuring the temperature of the surface before putting your pins into it.
Yep.
And can you speak to the value of understanding of that, and where Protometer sits, and why you can't calibrate it for that reason?
you can't calibrate the meter. You
To
cannot
the temperature.
Yes. Is that what you said?
Yeah, can you talk to it? Can you
Yeah,
can you
so,
talk to the topic of that?
So if I understand what you're asking, is that why there's an argument in regards to meters where they can look at surface temperature. There's an argument.
So you take a temperature, you use the gun, and
Yep.
you work out the surface temperature, and so then you adjust the meter and its correction factor to account for that temperature.
Okay, I that is an interesting topic. So the Australian Timber Flooring Association do use temperature gun to. I'm going to go one by one because I don't know that argument. So, however, if I'm looking at surface temperature, and why let's say Australian Timber Flooring Association will use what we call a scale measurement, which is back to our sorry, this is just going to be a little bit annoying. This is what we call a moisture correction chart. It will look at the temperature on the space. Sorry, the temperature gun will look at the temperature on the surface of the wood floor material, and that surface of that wood floor material with the ambient temperature will tell you that it is, let's say that it is Fahrenheit. I should have put a Celsius chart here, so we're going to use Fahrenheit time. Let's say that it is a 60% Fahrenheit, which is about, I think about 18 or 20. And the surface temperature is, and the relative humidity, the relative humidity is 40%, right? The relative humidity is 40%, and the temperature on the surface is 60%. it means that the wood moisture content would be 7.7%. Okay, so in this is American Standard. So in American Standard, a wood equivalent is 6 to 10. We are 9 to 14. Okay, so our wood moisture equivalent is that we want the wood to be reading in a moisture content of between 9 to 14%. If it's above that, in some materials, we'll consider that to be a little bit wet. If it goes over 20% in your moisture meter in the pin mode, what we call wood moisture equivalent, it will be the possibility of microbial growth will be possible. If it goes under 9%, the kiln drying is when the wood is cut from the trees. They have to go into a kiln. They dry it so they can stabilize that material to a certain point. And that certain point will always be around 10% moisture content. That's why the Australian standard is between 9 to 14%. If it's in Queensland, it's 9 to 15%, just around that. But so that's how all these measurement comes out from. So the argument that you're talking about is that, can we use this type of reading on gyprock? Probably not, because gyprock has not got that same testing regime as a timber and floorings that has been tested for many times. And because this chart is through the National Wood Flooring Association and the National Wood Forestry in USA, that looks at, you know, many situations to come out with a table of such. And in regards to, I think that's it. I don't know the argument, so I don't know what to say. But if we're looking at concrete, let's say that we're going to jump from wood and we look at concrete. If you have a concrete meter, and let's say that I'm going to take a protometer now, and I'm going to pin into the concrete, is that possible? You can.
It depends if you talk to someone who is a doctorate, they might say something different, but yeah.
I can pin it into it, but I would be pinning onto the leveling compound, or the screed, and that's not the concrete, and I might even break my meter, so I wouldn't suggest to do that,
No.
However, there are meters that look at gravimetric reading again, and the protometer uses its scale. Protimeter is protect timber is how the name came from. So it was built to look at wood materials. So their reading is from relative moisture content from wood moisture equivalent. A Trimex looks more on gravimetric readings. So they do their CME5 only looks at gravimetric readings. So they balance their meters through reading and measuring through concrete. That's their baseline. So you can understand that as much as protometer is really good in some ways, that sometimes the Trimex is actually better. So sometimes, like for me, I have 4 different types of meters, because I know that sometimes I just need a different meter, especially on a material that might be like concrete, especially if I'm going into a court case.
Can you just talk about that last point, regularly use the calibration?
Calibration is very important. In Trimex, they have a calibration plate. So you can buy calibration plate. I think they're about $120 so. So every time when you get into it, it's literally just a plate. You put your concrete meter on top of it. it will read between 3 and 4%. Just follow the sheet, and that will tell you that your meter is calibrated. There's nothing wrong with the meter. It is of what the manufacturer says that it is. You take that meter, register it into your report, take a photo of it, and then now you look at your measurements in your concrete, right? So you're following the recommendations from the meter manufacturer, and you're following their methodology in regards to how you're going to look at the concrete type. And that's the best way to do it. Same with Protometer. Is the Protometer for their pins, they come, the new MMS3 has it in the meter itself, and it is registered that you can just press, go into the settings. There's a settings, it looks at calibration. Go into calibration, there is a pin and also a pinless mode. So pinless mode, what you do is that you take the meter and you measure it about 1 meter away from the materials that you're going to read, and you push the calibration button. It will align itself, and then it will calibrate to the air and space, and then it will give you that it is calibrated or your meter is not calibrated. The pin meter is the same thing. The pin meter, you don't have to put it into the material. You can just press calibrate it, and it will tell you, yes, it's calibrated. She's 18.2, which is within the 18.1. 18.2 is always around the best scale of it. Most other meters will either, like a Delmois has a mesh, two pin plates that you can also do in calibration. Now, why do we do calibration? Calibration is to make sure that your meter hasn't skewed. So most meter has what we call a variation. If I put my meter in the fridge, like if I put my meter in a really cold condition during winter, I left it in the seat, it's -2. I go in, I take the meter in the morning, and I have to go and do a test. I will read the material incorrectly. So I might be reading a gyprock where the moisture content in that material is fine. And now, because the temperature in my meter is so skewed, that I'm looking at a false positive in my meter. So you always have to try not to put your meter in a too hot a condition and a too cold a condition, and make sure that the meter actually acclimate to the environment that you are going to measure in. I generally take my meter, put it on a table, open it up, have a conversation with homeowners, let it kind of climatize itself up, and then I start to, do my moisture meter reading. So calibration is very important, basically.
Do we ever have to calibrate the probes in the Protometer?
The Protometer, quick probes, all the moisture meter, the hydro stick, the little stick is used with a quick stick. They're called, sorry, let's try that again. They're called quick sticks, and they do need to be calibrated every year. This is a quick stick. The quick stick has very quick, it has ability to for it to climatize itself within a minute, so to the environment. So if I have to take it into a hot room and I read it, I can bring it into a colder outdoor area, wait for about a minute, and it will climatize itself. The difference with these quick stick meters is that they generally, after a year, a year or two, we throw it away. Or if we can get a salt pack and put it into a salt pack, we can probably let it climatize to 75% relative humidity. There is if you look at cigar companies, they actually have quick packs that you can buy, or what they call calibration packs, and they're generally about 20-something bucks for each one. And they're quite useful because you can put them in a pack and then they can calibrate. The Protometer also, Trimax also has a salt calibration system that you can buy. Generally, you have to leave it for 24 hours, and then it can calibrate like a test and tag system. You just register all the sensors has a serial number. You register it into your book and say that I've done a calibration of this meter, and you know when, how you did it. It went back to the recommended measurement in the salt pack, wherever you bought that from, and that would be quite sufficient. Does that?
Right. That's good. Any other questions?
Can I just ask a quick one, Evie? The Yuhu indoor air quality, without going into too much detail, what would be the best application at which stage of the project? Is that something that you would recommend when you find out there is a problem, or before, or, you know, like how? I'm just trying to quickly understand where the application of the Yuhu is best.
I've done it in many things. I've done it where the people goes in and go, I don't know. Hey, well, I don't know. And then you listen to what they're saying and you go, it doesn't look like there's anything wrong with this house. I've looked at some of the things. So that might be one of the times I say, hey, you know what? I'm going to send you a meter. I'm going to look it in there. And can you please, and I'll come and collect the data from you. And then that's one of the cases. The other case I might also go is that I've gone in and done an inspection and I just really don't understand what's going on there. So one of those sensors might also be able to help you to look at, you know, what is the issue. Sometimes it's not really the home. I've done many cases where, you know, you've gone in and they said, oh, my house is killing me. And then you're like going, well, I've done all the assessment. It's really not the home. Until you can prove it to the person that's living in the home, you can then go to the secondary and say, let's talk about other places that you've gone to. And they go, oh, you know, I went to this place. Oh, I had one particular case. We went and did 3 days of investigation. And we said, there's nothing. I can continue to come in here. There's no problems. Like I come in, you know, it's going to cost you money. I really don't think that I should be coming in. Anyway, we did all the stuff, and then I said, there is really, like, we can clean the place, but there's really nothing much. You put your shoes outside when you come in. That's the only place that has a little bit more, you know, growth that's coming out. But you keep your house really clean. I can, you know, there's nothing. So, and she goes, oh, there's nothing. What's happening? I said, let's talk about somebody. Let's talk about someplace else. And then she told me, she goes, oh, I've been living in the office. I'm in this small little room. And up there for 7 years, I've got this mold patch there. 3 days. 3 days of investigation. That is one of those cases.
I'll also be using I got the Aura. Is that what it's called?
Anyway,
yeah. I have the Aura because it's got an Ethernet cable and, you know, us BBs, but it can also do Wi-Fi if it's not plugged in. But I'm using it for a basic indoor air quality assessment of a shopping center.
Oh.
So that's
you should come back and tell us a little bit more about that next time.
Oh, I can do that, sure.
How is it? Aura, did you say?
Yeah, it's the bigger one that Evie showed the picture for. So there's the home one that's like the size of the microphone, or there's the Aura, which is like the size of a book.
Yeah.
And it's got a lot more features about it.
Yeah. It's got 13 parameters. So if any one of you are going to do, that's how you can see trend readings in a building. You can leave it on a building and look at what's going on. And you can write more and more effective reports for your customer. It's also has you can see that it has 13 parameters: temperature, humidity, carbon dioxide, carbon monoxide, PM 2.5, PM, all the PMs, PM1, virus, PM4, PM 2.5, PM4, anything that can actually go in and causes effects in your respiratory systems. And then PM10. And then, of course, light and sound. Light and sound is what we call the sustainable living. So the Green Neighbors rating uses light and sound. So if you're going into a commercial property and they say, I've got Neighbors rating, then this is the type of monitor you would be able to go in and help them to analyze what Brian is doing to see what's happening with the indoor air quality. Because understand, you're not just looking at building the EMF of buildings or mode. You are really you're a building biologist that have a unique training that lets you look at all the impact in a building for the health and well-being of the occupant. So all that factor you need to understand how that works. And sometimes an indoor air quality monitor is very, very useful.
Excellent. Thank you.
No worries.
All right. Well, if nobody has any more questions, we can wrap it up. No more? No. Thank you so much, Evie. We appreciate that.
Thank you all for your opportunity to talk here. Hey.